Chapter 1.5 is about applications of those quadratic equations we talked about last time. People generally have a lot of problems with the applications, aka word problems, because they're all so different. They involve different techniques. Usually in math we can come in and we can put up a list of steps and say, okay, here are the steps that you perform every time you're solving this type of problem. For example, on the quadratic equations, we said, first of all, check to see if you can use the square root method. Then try factoring. Then try completing the square. Then try quadratic formula. On completing the square, here are the steps. First do this, then this. But applications aren't quite like that. So I just have a sample of a few of the applications, kind of a general form of the different kinds you can expect to see. Let's go through them. First of all, we have the sum of the squares of two consecutive odd integers is 202. Find the integers. Okay, I need to know what this consecutive odd integers mean. Does anyone know what the word consecutive means? Consecutive means in a row. So 5, 6, 7, 8. Those are consecutive numbers. Right? 21, 22, 23. Consecutive in a row. So our algebraic method, if we know that numbers are consecutive, are to use x plus 1, of course, the very next number, and x plus 2, the very next number, and x plus 3, depending on how many we need. Right? That'll get us consecutive numbers. This one says consecutive odd. So consecutive odd integers are like 5, 7, 9, 11. Right? So if I started with x and I wanted the next odd number, I'd have to add a 2 and add 2 more, or in other words 4 to the original number to get the next odd number. This works, this is our method for either consecutive odd or consecutive even. Because if x is 5, this will give me 7, this will give me 9. But if x started out being 6, this would give me 8, this would give me 10. So consecutive integers, consecutive odd, or consecutive even. So first of all, I've got to know that information. And then I have to be able to interpret these words. So the sum, right, of the squares, which would mean I'm going to add 2 consecutive odd integers. So here's my consecutive odd integers. And I want to sum their squares. Right? The sum, here's the sum of 2 squares. And is, of course, is equal 202. And there's my equation. Now be careful. Notice the difference in the word. The square of the sums would look like this, which is a completely different thing, right? This is the square of the sums, but this is the sum of the squares. Now, once I have my equation, we can solve any quadratic equation after that last lesson. So I'm just going to multiply this out. Here this is again, right? So I hope we very quickly learn the shortcut to multiplying out these perfect square trinomials, right? X squared plus 4x plus 4 equals 202, because you square the first one, you multiply everything together, so 2x, and double it, and square the last one. Now I'm going to set it equal to 0, because the first thing I'm going to do, I see I can't use the square root method. So my second choice is I'm going to try to factor it. So 2x squared plus 4x, if I subtract 202 from both sides to set it equal to 0, I get negative 198 equals 0. I notice they're all even, so to make my math easier, because I have an equation, only because I have an equation, I can divide this 2 out as long as I do the same thing all the way across. If I'm simply factoring an expression, I cannot divide the two out. I would have to factor it out, right? But because I have both sides, I can make my numbers smaller, therefore easier to work with. Come up with x squared plus 2x minus 99 equals 0. So I'm looking for two numbers that multiply to give negative 99 and add to give 2. Those two numbers are 11 and negative 9. So x plus 11, x minus 9 equals 0, means x equals negative 11 or x equals 9. Now, find the integers. It doesn't say anything about positive integers. It just says 2 consecutive odd. So if x is negative 11, x plus 2 is negative 9. There's 2 consecutive odd integers. And if x is 9, x plus 2 is 11. So here's 2 more consecutive odd integers. Okay, what about this one? Zach wants to buy a rug for a room that is 12 feet wide and 15 feet long. He wants to leave a uniform strip of floor around the rug. He can afford to buy 108 square feet of carpeting. What dimensions should the rug have? Don't forget that drawing a diagram is a really useful technique. So I know that I've got a rectangular room, and he wants to put a, we're going to imagine that's a rectangle, right? Oh, all right, that's just too bad for me to leave. So let's fix it. All right, and he wants to put a rectangular rug in the middle that leaves a uniform strip around the floor. And we know that the room is 12 foot wide and 15 foot long. Okay, and we don't know how much this is, but he wants it to be uniform. So whatever it is, it's going to be the same distance from the wall to the rug all the way around. He can afford to buy 108 square feet of carpeting, so I know that the area of this rug is 108 square feet. Oh, area. I know that the area of a rectangle is length times width. Okay, so I know the area of this rug is going to equal 108. All I have to do is figure out the length and the width of the rug. The length of the rug is 15 feet minus x minus x. 15 minus 2x, right? If I'm going to leave 2 foot all the way around the rug, then 15 minus 2 minus 2, or 15 minus 4, would be the length of my rug. So what would the width of the rug be? 12 minus x, or 12 minus 2x. And there I have an equation. Area is length times width. And I know the area of the rug. This would be the length and width of the rug. So I can solve that. First thing I've got to do, use my distributive property to multiply that out. So 108 equals 15 times 12, 144 plus 36, 180 minus 30x minus 24x. Wait, where did I get 30x? Okay, sorry. Minus 24x, lost myself for a second, plus 4x squared. Oh, I got a quadratic equation. I can't use the square root method, so I'm going to try to factor it, which means it needs to set equal to 0, and I'm going to put it in descending order. I can combine these like terms, so I get minus 54x, and if I subtract 108 from both sides so that it sets equal to 0, I have plus 72 equals 0. Again, I notice that they're all even numbers. Now, they're not divisible by 4 because 54 is not divisible by 4, but I can at least divide that 2 out to make my number smaller, giving me 2x squared minus 27x plus 36 equals 0. Okay, let's move this out of the way. All right, so I'm going to try to factor this. I would need, or whatever your factoring method is, right, two numbers that multiply and give 36 times 2, so 72, and that add to give negative 27. Well, I know 72 is 9 and 8, but 9 plus 8 is 17, so those aren't my numbers. But that gives me a starting place here, because I can break these down to like 3 times 3 and 4 times 2. So I have lots of options here. I've got, there's my 36 times 2. I can do 6 times 12. I can do 24 times 3. Oh, 24 times 3. 24 times 3 is 72 when I multiply, but 27 when I add them. Right numbers, wrong signs. I need negative 24 and negative 3. Still positive 72 when I multiply, but now it's negative 27 when I add them. So if we know a little shortcut for factoring, I can just put those numbers in my factors, divide by 2, don't forget about the effect this coefficient has, leaving me x minus 12 and 2x minus 3 for my factors. So either x is 12 or x is 3/2. Now, make sure you answer the question. What dimensions should the rug have? And remember what our x is. X is the blank space in the floor that we want to leave between the rug and the wall. So I've got to decide 12 feet. Well, shoot, the room's only 12 feet wide. I can't leave 12 feet over here and 12 feet over here, or 12 feet here and 12 feet here. So that's not my answer. It must be this 3/2, or in other words, 1.5 feet. But again, that's not my answer. That is the blank space in the room. So if this is 1.5 feet and this is 1.5 feet, then the rug is 15 minus 3, or 12 feet long, and 12 minus 1.5 minus 1.5, or 12 minus 3, 9 foot wide. So the rug I need is 12 foot by 9 foot. Oh, sorry, forgot to erase it. Okay, one more. Grady is flying a kite on 50 feet of string. Its vertical distance from his hand is 10 feet more than the horizontal distance from his hand. Assuming that the string is being held 5 feet above ground level, find its horizontal distance from Grady and its vertical distance from the ground. This is another one where we might want to make a diagram. All right, so he's flying a kite, right? All right, on a piece of string. 50 feet of string. So I know that this is 50 feet. Its vertical distance from his hand, so you can either think of this distance over here, vertical from his hand, right? Vertical from his hand, or this distance up here. Either way, the vertical distance from his hand is 10 feet more than the horizontal distance. Well, it doesn't tell us this horizontal distance, so let's use x, and then the vertical distance is 10 feet more. Assuming that the string is being held 5 feet above ground level, so again, this is 5. Find its horizontal distance from Grady and its vertical distance from the ground. Oh, this is a right triangle. And with a right triangle, what formula do we know about the right triangle? You guessed it, I'm sure. A squared plus b squared equals c squared, where this must be c squared. Either of these can be a and b. So that gives me my equation. A squared plus b squared equals c squared. And I've got a quadratic equation again that I can solve. So x squared, here it is again. Very beneficial to know that shortcut. Square the first one, multiply everything together, which gives us 10x, and then double it for 20x, and square the last one. Equals 2,500. I want it set equal to 0 because I can't use the square root method, so I'm going to try to factor it. So combining like terms, I have 2x squared plus 20x, subtracting 2,500 minus 2,400 equals 0. Once again, I can make these numbers smaller, making my factoring much easier. If I divide a 2 out, leaving me x squared plus 10x minus 1,200 equals 0. So I need two numbers that multiply to give negative 1,200 times 1, negative 1,200, and add to give 10. I might notice these two extra zeros and one here, so I can just kind of think about, oh, numbers that multiply to give negative 12 and add to give 1, that's 4 and negative 3, right? But since I've got these zeros, how about 40 and negative 30? So x plus 40 times x minus 30 equals 0. 40 times negative 30 is negative 1,200. 40 plus negative 30 is 10. Meaning we have x is negative 40 or x is 30. Now once again, make sure you've answered the question. Okay, and we want the horizontal distance from Grady, right? That's x, but negative 40 can't be a distance. So x is 30 feet. That's the horizontal distance. And then we also want the vertical distance from the ground. Well, the vertical distance to his hand is x plus 10, but then he's holding it 5 feet above the ground. So the vertical distance is x plus 10 plus 5. No, and if we know x is 30, right, then we have 30 plus 10 plus 5, or 45 feet from the ground.